Hi, my name's Judy and I'm from H2O for Life. We're going to spend a few minutes together learning about the World Water Monitoring Challenge. It's a program for students just like you that is put together by the Earth Echo Institute, who it was founded by the son of Jacques Cousteau. Kids around the world have an opportunity to become citizen scientists by doing some simple water monitoring testing and then uploading the data to the Water Monitoring Challenge website. Your school is receiving kits that look just like this, and I'm going to show you how to use them. First thing you need to do is collect some water from a natural water source. If that's not available to you, that's okay. You can still use these wonderful science kits as a classroom experiment experience. When you get your kit, and once it's all set up, there are basically 4 tests that we're going to be measuring from our water source. The very first one is temperature. The temperature indicator is added to the outside of your reagent cup, and you simply put it down into the water and you hold it under the water for about 60 seconds, and then you're just going to lift it out of the water with the water still in it, and you can read your temperature from the tape. The number that glows green is your temperature in degrees Celsius. The next experiment you're going to do is pH. Now, why do we test pH? Well, pH is an indicator of whether the water has an acid quality or a base quality. What that actually simply means is that if the water is somewhere either lower or higher than the neutral 7, scientists sometimes wonder why, and it gives them an indication that there could be some issues or problems going on in the water. To take your pH measurement, you fill up your pH reagent tube. It's the taller of the 2 that's in your kit, and you're going to use a pH reagent tablet. There are 2 foil tablet containers in your kit. One says wide range pH. The other says DO for dissolved oxygen. pH goes with the pH tube. To put your reagents in, it's really easy. Remember, your foil has bubbles on one side, bubble up. So make sure you keep the bubbles on the upside, and then you simply press, and a tablet will fall into your reaction container, and then you're going to shake, and the tablet's going to dissolve. Once the tablet completely dissolves, you're going to do a color comparison. You simply take your tube, you place it in front of the pH color chart, and you choose the color that's closest to the one in your tube. It looks like this water is very close to neutral 7. The next test you're going to do is dissolved oxygen. Dissolved oxygen is important because all of the living things that are in the water require oxygen. If the oxygen levels are very, very low, it could mean that the body of water is, again, in trouble. If the oxygen levels are very high, well, one of the things we have to take into account is the temperature of the water, because that can change the dissolved oxygen levels. Let me show you how to do this test. Very small, your reaction container. So take the smallest one, fill it all the way up, and this is really important. You have to fill it so full that not a single another drop can get in, because if an air bubble gets trapped, we're going to be measuring the oxygen in the atmosphere and not in our lake. Dissolved oxygen reagent tablets are used for this one, and you need 2. You can remember 2 because oxygen's chemical formula is O2. Bubble up, pop your tablets in, 1, 2, cap it, and then you're going to shake. This one takes about 5 to 7 minutes of shaking. So don't get discouraged, just keep shaking and those tablets will dissolve. Once they're dissolved, you're going to do the same procedure you did with pH. You'll take your reaction tube once the tablets are dissolved and compare the oxygen level to the color on the chart. In this case, I have an oxygen level that looks like it's near 0. The last test you're going to do, and I need to pour this water out and then put some back in, is something called a turbidity test. Now, if you can see inside my container, there's a little black and white pattern. That's called a Secchi Disk. to test the turbidity, which is the amount of stuff that's floating around in the water that prevents sunlight from getting through the water and down to the bottom. You're going to fill up your cup. You're going to place it down on the table, and then on the right-hand side of your chart, you'll see that there's that same pattern. And above the word is turbidity. All you need to do is place this down on the table, look through the water, and look for the Secchi disk, and then compare. Does it look really sharp? Is it a little bit clouded, or is it very cloudy and hard to see? In this case, my water sample is very cloudy. So my turbidity measurement, I read off here, it's 100 JTUs. Okay? Now all the testing that we're going to do with the kid is done. The very last thing we need to do is determine the percent saturation of oxygen in the water. And that really is just a measurement we get from a chart. So here's a scoop on that. Oxygen in the water is temperature dependent. The colder it is, the more oxygen the water can hold. The warmer the temperature of the water, the less oxygen it can hold. So the percent saturation tells us, well, if there's a good measure of oxygen in the water, but it's too warm, that oxygen can't get across the gill membranes of things like fish. And so the percent saturation is a very critical number. We take the temperature we read from the water. In this case today, it read 18 degrees Celsius. And then I read across, and let's say I had 4 parts per million of oxygen. That gives me a 42% oxygen saturation. Now you've got your 4 important measurements for this body of water. You simply need to go to your computer to watermonitor.org, and you can upload your data individually or as a class. That data will then once a year be analyzed by scientists around the world so that they can get a snapshot of what's happening in different bodies of water at different times in the season and over a number of years. Thank you for becoming a citizen scientist, and I hope you enjoy working a little bit with water quality analysis.